All right. Question number 4 from Mayport. That'd be good. Okay. Okay, yeah, sure. All right. There is, and I'm gonna make sure I gotta make sure I word this correctly. There is nothing for which I am not cool enough. I am cool enough for literally everything. Thank you, Ian. He said Thatch just isn't cool enough for Beyblades. I'm cool enough for Beyblades. I'm cool enough for anything. They're just not cool enough for me. Okay, children are weird. Okay, let's go here. On what intervals is the graph of G concave up? Yep, I do say so. Okay. G is the integral from 0 to x of f. This is the graph of f. Okay? So we want to know when is G concave up. That means that G double prime has to be greater than 0. Everybody good with that? So we need to figure out how is G related to f. Well, G prime ought to equal what? Should be f, which means that G double prime ought to be f prime. So if we want G double prime to be positive, that means we want f prime to be positive. F prime in terms of this graph means the slope of the graph is positive. So anywhere where the function is increasing, where f is increasing, would be when its slope is positive. Right? So positive slope up here, right? -4 to -2. Also, that's the negative here, positive from 2 to 6. Everybody good with that? -4 to -2 or 2 to 6? Any issues there? Yes. Yeah. Specifically, well, for 2 reasons. One, because it specifically says open intervals, but also because the College Board never wants you to indicate concavity using brackets ever. Right? They want you to for increasing and decreasing, but not for concavity. Everybody good with that? And obviously, like I said, I don't have the scoring guidelines for these, so I can't tell you how many points this was worth, but usually they associate a point in problems like this with indicating that like G double prime is equal to F prime. So make sure you write something like that in your work, because usually there is a point associated with that. Not every time, but I would say like 80% of the time there's a point associated with that. So I suggest doing that. All right, for part B, we're going to have a new function, P of x. P of x is G of x times F of x, and we want to find P prime of 3. So if P of x is G of x times F of x, then P prime of x ought to be the derivative of this product of 2 functions. So we use the product rule. So it'll be G of x F prime of x plus G prime of x F of x. Everybody good with that? And it asks us to find P prime of 3. Is that right? Was it 3? 3. So that ought to be G of 3 times F prime of 3 plus G prime of 3 times F of 3. So then we just need to go back and look at our graph and figure out what all of those different things are. So G of 3 would be the integral from 0 to 3 of F of x. Everybody agree with that? Okay. People at home, you good with that?
Yeah.
Okay. So from 0 to 1, I don't know what that happens to be. What is that? I mean, it's, what is that, 2? Same thing over here, though. This is a -2 from 1 to 2. Those two, this area right here and this area right here are going to cancel each other out. So then we've just got the area from 2 to 3, which is a trapezoid. Right? Trapezoid should be base 1, which is 4, plus base 2, which is 3, divided by 2, times the length of the interval, 1. So what should that come out to be? 7/2, which is a -7/2 because it's below the x-axis. Everybody good with that for G of 3? Yeah? All right, F prime of 3. So that's the derivative of F at 3. So that's the slope of F at 3. Well, what's the slope here at 3? Looks like it's going up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, right? So it looks like a slope of 1. And then plus g prime of 3. Well, what's g prime? G prime is f. So we just want f of 3. F of 3 is negative 3. Oh, and then f of 3, which is still negative 3. So we end up with negative 7/2 plus 9, which ought to be what, 11/2? Yeah. Because it's below the x-axis. So anytime you take an integral below the x-axis, the value can be. That's why this top red triangle and this bottom red triangle cancel out, because the top one's positive, the bottom one's negative. Everybody good there with part B? Any questions on that? Leopold, is that what you got on the AP test? Pretty sure. All right, I'll take it. Good. Good. Everyone's good? Zoom, are you good? Zoom.
We're good.
Wonderful. All right, part C. Find the limit as x approaches 2 of g of x over x squared minus 2x. Oh, that's g of 2 over 0. I bet g of 2 is going to be 0, and this will be an indeterminate limit. Let's go check. Oh, look, g of 2 ought to be the integral from 0 to 2 of f. And we already did that, right? That's the top triangle and the bottom triangle. They cancel each other out. So g of 2 is 0. So this is 0 over 0. It's indeterminate. So on the AP test, you will write out using L'Hopital's rule. This
Do we
is
have to write it out, or can we just put LH?
Nope, they've indicated in the last couple of years that if you write LH, they do not want that. They want you to write it out. As stupid as that is. So we'll take the derivative of the top and the derivative of the bottom. Derivative of g is g prime. The derivative of x squared minus 2x is 2x minus 2. So our denominator is going to become 2. And our numerator is g prime of 2. Looking back at our graph, well, we know what g prime is, right? G prime is f. So we go back and we look, what is f of 2? F of 2 is negative 4. So this is negative 4 over 2. We end up with negative 2. Everybody good there? Yeah? Good with that, Leopold? Yeah? All right. Good. You use L'Hopital's rule on the AP test on that? Yeah? All right. Yeah, good, good. All right. Any questions? Everyone's good? Okay. Was there part D to that one? I'm going to pretend like there was. Yeah, find the average rate of change of g on the interval from negative 4 to 2. Okay, so first off, find the average rate of change of g on negative 4 to positive 2. So how do we do that? How do we find the average rate of change? What is average rate of change? Average rate of change is just a slope. G of 2 minus g of negative 4 over 2 minus negative 4. So that's a 6. What's g of 2? We already did that a second ago, right? G of 2 was 0. And g of negative 4, we're going to have to figure out what g of negative 4 is. I don't think we found that yet, did we? No. So g of negative 4 ought to be the integral from 0 to negative 4 of f, which will make the opposite of the integral from negative 4 to 0 of f of x. And then the integral from negative 4 to 0, well, that's, got to figure out what that area is. Probably easiest if we split that into a triangle and a trapezoid. Yeah. So the triangle ought to be 1/2 the base of 2 times the height of 6. And then the trapezoid ought to be base 1, 6, plus base 2, 4, over 2, times the height, which is 2. So what does that come out to be? Negative 16. So 0 minus negative 16, which is 16/6, or 8/3. Everybody good with that? All right. And then does the mean value theorem guarantee a value C on -4 to 2 for which G prime of C is equal to its average rate of change? Okay, so what are the initial conditions for the mean value theorem? Mean value theorem says that the function G must be continuous and differentiable. True? Okay. So in here, it says that f is continuous. Okay. So if f is continuous from -4 to 6, that means that the derivative of g, which is f, exists everywhere on that interval, doesn't it? Yeah. And if the derivative exists everywhere on that interval, then that means that that function must also be continuous and differentiable, right? So if the function is differentiable, the function is also continuous. So you should be able to say that yes, there should be a place somewhere on this interval where our value, according to the mean value theorem, is equal to that, where that derivative is equal to whatever it was, 8/3. Because g is continuous and it is differentiable. Everybody good with that? F itself is not differentiable on that interval, but that's okay. Right? It's not, we're not talking about whether f is differentiable, we're talking about whether g is differentiable. And if the derivative of g exists at every value on that interval, then g is differentiable on that interval. Everybody good there? Yeah? People in Zoom, you good?
Zoom good.
Zoom good. All right. Let us consider the function y equals f of x, whose curve is given by the equation 2y squared minus 6 equals y sine x for y greater than 0. That'd be fun. Let's show that dy dx is this. Okay, great. So all that is can you take a derivative implicitly? Right, that's all that's asking you. So for part A, the derivative of 2y squared with respect to x ought to be 4y dy dx. Derivative of minus 6 ought to go away. Equals derivative of y sine x needs to be done using the product rule. So we'll have y derivative of sine plus sine derivative of y. Everybody good so far with that? Yeah. And we'll subtract the sine x there over to the other side. So we'll have 4y minus sine x. And those are all being multiplied by dy dx is equal to y cosine x. And then you just divide. And you've shown that. Good? That part was probably pretty easy. Everybody good with that? Yeah. Okay. All right, part B, write an equation for the line tangent to the curve at 0, √3. So in order to write a tangent line equation, what do we need? We need two things. We need a point and a slope. So to find the point, we look right there, and there's the point, 0, √3. To find the slope, we need to plug 0 and √3 into our derivative. So we'll evaluate this at the point 0, √3. When x is 0 and y is √3, that numerator becomes √3 times 1, right? Or just √3 over 4 √3 minus 0. So what does that come out to be? √3's ought to cancel out. Should just become 1/4. Everybody good there? This is a y-intercept, right? 0, √3. So you can just write y equals 1/4 x plus √3 if you want, or if you want to write y minus √3 equals 1/4 x times, or 1/4 of x minus 0, that's fine too. But point slope or slope intercept, the other one's good. Everyone good? Zoom, good?
Good Zoom.
Good Zoom. All right, part C. For x between 0 and pi, for y greater than 0, find the coordinates of the point where the line tangent to the curve is horizontal. So if the tangent line to the curve is horizontal, what does that tell us? That the derivative has to be 0. If the derivative is 0, we have to set the numerator of our derivative equal to 0, which was y cosine x equals 0, right? And we don't need to worry about the y because it said y is greater than 0. So if y is greater than 0, nothing that y is going to make this thing equal to 0. Doesn't matter, y will be insignificant towards it becoming 0. So really, we just need to know when does cosine x equal 0 on the interval from 0 to pi, and when is that at x equals
Pi halves.
pi over 2. Did it ask anything else in that? Find the coordinates of the point. Yeah, so if x is pi over 2, then we got to go back in over here. 2y squared minus 6 equals y times, was it sine? I assume it was sine of pi over 2, right? And sine of pi over 2 is 1. So really that's just 2y squared minus y minus 6 equals 0. So we'll factor that out. What is that? Y equals negative 3/2 and y equals positive 2. And it asked us for y to be greater than 0. So that'd be y equals 2. So our coordinates are pi over 2, comma 2. Good. Any questions on that part? All right. Is there more to this one? Yeah, determine whether f has a relative min, max, or neither at the point found in part C. Okay. Justify your answer. So how do we go about doing that one? Yeah, second derivative ought to do that for us, right? So we'll take the derivative of this. So the second derivative. Okay, what was our first derivative? So we need 4y minus sine x in the denominator. Or in the first thing, that's our denominator. 4y minus sine x times the derivative of the numerator. So times the derivative of y cosine x. What's the derivative of y cosine x? That ought to be y times negative sine x plus cosine x times dy dx. I should have really written this a lot smaller. Perfect. I missed a parenthesis. And then minus what? Minus y cosine x times the derivative of 4y minus sine x, which would be 4 dy dx minus cosine x. All over the denominator, which was 4y minus sine x squared. And the point that we're looking at here is the point where x is pi over 2 and y is 2. Is that right? And what do we know about dy dx at this point? It was 0. So do I need to replace the dy dx's that I have in here with my original dy dx? No, I know they all equal 0, so I can just replace those dy dx's with 0. So I'm going to replace all of my x's with pi over 2, all of my y's with 2, and all of my dy dx's with 0. So we've got 8 minus, and then what's the sign of pi over 2? 1. So we got 8 minus 1, and then we got negative 1 times 2. And we know that dy dx is 0 because we were right here. We were talking about we were looking for when the tangent line to the curve was horizontal, so the derivative was equal to 0. So dy dx is 0. All right, if we plug in our point of pi over 2 into that, it just comes out to be 0. Okay. All right, sorry, so what do we have? We had -2, that was our negative sine xy, or negative y sine x, yeah. Plus, and then that just becomes 0 because the dy dx is 0, right? And then minus y times the cosine of pi over 2. Well, what's the cosine of pi over 2? 0. So this whole term here, this is 0 times something. So that's just going to be 0. And we can divide that by our 4y, which is 8, minus our sine of pi over 2, which is 1 squared. And so what do we end up with? We end up with negative 14 over 49, or negative 2 over 7, which doesn't really matter that it's negative 2 over 7. What matters is that it is less than 0. Right? If it's less than 0 at a critical value, then that tells us that the function is concave down, which tells us that that critical value yields a maximum. Good or no? Everyone's good with that? Zoom, are you good with that?
Yeah.
People here, you good with that? All right. Wonderful. One more to go. A medication is administered to a patient. The amount in milligrams of the medication is modeled by y equals a of t that satisfies this fun differential equation 12 minus y over 3. At t equals 0, there's 0 milligrams of medication in the patient. They've given us a slope field. We want to sketch the solution through the point 0, 0. So here's 0, 0. Looks like it should do that. And I think I told you guys don't put an arrow at the end of this thing, right? And I just tried to put it in. But yeah, it's going to approach this horizontal asymptote. And it does continue out forever towards infinity that way, but this is what they want to see. Everybody good with that? That part should have been pretty easy. Part B, using correct units, interpret the statement, the limit as t approaches infinity of a of t equals 12 in the context of this problem. Okay, so as t goes to infinity, a of t goes to 12. So what is that telling us? That, right, it's a horizontal asymptote, that there's a horizontal asymptote of y equals 12. But within the context of the problem, what does that mean? Exactly, but I'm talking about in the context of the problem, we're administering medication to a patient, and no matter how far into time we go, yeah, exactly, the maximum amount, or so we'd say something to the effect of, you know, the graph, we probably want to put both things. The graph approaches, or the graph of a of t approaches a horizontal asymptote of a equals 12, the patient will never have more than 12 milligrams. Let's rewrite both those words. Will never have more than 12 milligrams of medication in their system. Something to that effect. Something like that would be good. Everybody good with that? Yeah. No, I think if you just put the second part, that's fine. But I think, because I don't have the scoring guidelines in front of me because they haven't released them, but I would say, because it does say in the context of the problem, so you don't probably need the mathematical horizontal asymptote part. And make sure you include the units, milligrams. Right. All right, everybody get there with B? Yeah. All right, part C, we're just going to separate the variables and find the particular solution with the initial condition that a of 0 is 0. So We got dy dt equals 12, what was it, 12 minus y over 3. Right? So we'll have dy over 12 minus y equals 1/3 dt. We'll integrate both sides. The right side just becomes 1/3 t plus constant. And dy over 12 minus y, how do we integrate that? It's a u sub, u equals 12 minus y, which when we do that, u sub ends up giving us a negative natural log absolute value 12 minus y. Everybody good there? And when t is 0, y is 0, so negative ln 12 equals the constant. So we will go in and say that negative natural log absolute value 12 minus y equals 1/3 t minus ln 12. We'll divide by the negative to get natural log absolute value 12 minus y is ln 12 minus 1/3 t. We'll exponentiate to get absolute value 12 minus y is equal to 12 e to the negative 1/3 t. Bringing that 12 out to the front. We'll clear off the absolute value, recognizing that the amount of stuff in here needs to equal 0, right? So I need to be, if I clear off the absolute value, when t is 0, y needs to be 0, which means that I'm going to have 12 is equal to 12 e to the 0, which is correct. So I don't want to put a negative in front of there when I clear off the absolute value. We're just going to leave it as the positive. Otherwise, if we put the negative there, then this is not a true statement at our initial condition. So we need to keep it as the positive version. And then I'll just add the y over here and subtract the other. So we end up with 12 minus 12 e to the negative 1/3 t. And we'll say a of t is equal to that. Good? Yeah.
Would it be like, is the work you did, would that be enough work done for the, that's like,
Oh, yeah. Yeah, oh yeah, they don't care if you write after you said. Yeah. Any questions on that? Everybody okay with that? Are you all now wishing you'd taken the May 4th test? No? No. Leopold, are you wishing you'd taken the, oh wait, no, you did take the May 4th test. How'd you do? Did you get that one right? Perfect. It's always the right answer, even if you got it wrong. Just tell me you did. And then I'll shut up. All right. Gravel? Yeah, gravel problem. This one, the first one we did today too, was one of the nice little graph problems, right? That was good practice for the quiz tomorrow on the graph and the rate FRQs. We didn't do a rate one though, did we? Was this one a rate? That wasn't a rate. We didn't do a rate. Well, there was no rate question on the May 4th test. Weird. All right. Rate FRQs. Let's do the rate FRQ gravel problem. You guys all did this one already, right? Yeah. Calculator problem. So hopefully you've got the right answers from your calculator. We have unprocessed gravel arriving at the gravel processing plant, and we have a function g of t, and we have an initial condition that at t equals 0, there are 500 tons of unprocessed gravel. So we're going to need to at least keep that in the back of our heads that there's an initial condition. It may or may not be required. Usually it's required to use it somewhere. And they also tell us how quickly the plant processes the gravel to get rid of it, right? 100 tons per hour. So we got two different rates: the rate at which the unprocessed gravel arrives, the rate at which it is being processed and leaves, and then the amount of unprocessed gravel that starts. First thing we want to find is g prime of 5. That's just a calculator thing. Just write g prime of 5 equals and put an answer. Your calculator will tell you what the derivative of that is at 5. You don't need to take the derivative of that. You know how to take the derivative of that if you had to, right? The 90 would go away, and you'd just get, 45 times the negative sign of t squared over 18 times the derivative of t squared over 18. You could do that, But don't do that in the calculator section. Just have the calculator tell you G prime of 5 is negative 24.588. Do people agree with that?
Yeah.
You got what? What did you get? Huh. Maybe you typed 44 or something. I don't know. Everybody else got negative 24.588? Okay, yeah. You screwed up, I assume. All right, and then using correct units, interpret the answer in the context of the problem. So the correct units for this, well, G of t is measured in tons per hour, right? So the derivative of that ought to be tons per hour, or tons per hour squared. Tons per hour squared or tons per hour. The context of this is that the rate at which the unprocessed gravel is arriving is decreasing at this rate, at 24.588 tons per hour. So the rate at which it's arriving is slowing down, is decreasing. Does that make sense to everybody? Everyone's good there. All right, part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. The hours of operation are 0 to 8. So the amount that arrives, we don't care how much was there at the start. We don't care how much is processed. We care only about how much arrives. So that ought to be an integral from 0 to 8 of g of t dt, which is 825.511. 5 tons. That's a lot of gravel. Right. Everybody good there? That part's pretty easy. Part C, is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? So how do we figure out if that amount of unprocessed gravel at the plant is increasing or decreasing at t equals 5? Has to do with the rate at which it's arriving as well as the rate at which it's being processed and leaving, right? We want to know the actual amount. The actual amount of gravel, we'll write this out. We'll say the amount of gravel, we'll call it A, the amount of gravel is equal to 500, the initial amount, plus the integral from 0 to some t value of, what was it? Was it g? That's the function, g of x, minus what? How much is being removed? 100 tons per hour, so 100 t. Well, we could write it the integral from 0 to t of 100, but 100 t is good enough. So a prime, the rate of change of the gravel, is just g minus 100. So we're wondering then if that was a t equals 5, I think. Yeah, t equals 5. Okay. So is the rate at t equals 5 positive or negative? So g of 5 minus 100, what did that come out to be? Yeah, it be negative. Do we have a number? Anybody get a number on that now? Yeah?
G of 5 was 98.1, so 1.9, I guess.
Is that what yeah? Negative 1.859, which is less than 0. So it should be decreasing.
Do we need that first equation? Because I just went to a prime and just used
No,
that.
if you just wrote this, that's fine. I just like to set this one up because oftentimes some part of the problem will ask us how much gravel there is at a certain time. And so I like to have that equation already there. And just because if it does, even if it doesn't ask in this problem, it's helpful to people to see what that equation is because they sometimes ask for that. Yeah, for example here, what is the maximum amount of unprocessed gravel of the plant during the hours of operation? We're going to need this equation right here to figure out the maximum amount of unprocessed gravel of plant. And so part D, we need to figure out when the derivative of this is equal to 0, which would be when is g of t minus 100 equal to 0, and when is that true? Anybody get a value for that? Do I need to pull up? I can pull up the guidelines so I know what the value of that is, but I don't have it. 4.923. Does that sound right to other people? No?
Yeah.
Yeah? Okay. All right. Cool. So our only options then are at t equals 0, t equals 8. That was right. That was how many hours we had in our workday. Yeah, t equals 0, t equals 8, or t equals 4.923. So A at 0 should be what? Yeah, at 0 it should be 500. I should probably write this out as t and the amount of gravel. At 4.923, you should have plugged that into this equation to get what? Sure, it sounds good. And at 8, you should have plugged in 8 to get what? 525.551. Okay, sure, sounds good to me. So which one is that? They asked for a max, right? Yeah, so our maximum occurs at this value, 4.923. And it says, what is the maximum amount? Right, so the maximum amount is 635.376 tons. Everybody good with that? Cool. Wonderful. The interpretation for part A was that the rate at which the unprocessed gravel is arriving is decreasing at this amount, at 24.588 tons per hour squared. Rate is decreasing. Everybody good there? Question? D? Yeah. No, this is good enough right here. Yeah. Other questions? The 100T comes from right here. They're processing the gravel at a rate of 100 tons per hour. So 100 times whatever number of hours, 100T. Right, your integral of 100. Any other questions? All right. Should we do another rate problem? Should we do another graph problem? What do you guys think? We got time for one problem. Rate or graph, your choice.
Graph.
Okay, great. Guess I had to open up the thing that says graph FRQs. All right, what was the last graph one we did? We did this one, right? But we did not do this one. All right. Here's a graph problem. I will give you, if I give you 15 minutes, we should have just enough time to finish it. So you have 15 minutes. Ready, go. All right. G is the integral from -3 to x of f. This is f. Find g of 3. That'd be the integral from -3 to 3 of f. So here's -3, right? Yep. Here's 3. Integral from -3 to 3 ought to be this first triangle, which ought to be 1/2 the base, which is 5, times the height, which is 4. And then minus whatever this little triangle down here is. What is this little triangle? Should be 1/2 of the base, which is 1. And then the height, what's the height of this? Should be 2 if you look at the slope of that line. So we end up with what? 10 minus 1? 9. Yeah? Everybody good there? Everybody all right with part A? Zoom.
I'm all right with that.
Okay, great. All right, part B. When is G increasing and concave down? So increasing if G prime is positive, concave down if G double prime is negative, right? G prime is F. G double prime is F prime. So we want to figure out when is F above the x-axis, but also when is the slope of F negative? So when is F decreasing? So F is above the x-axis, but decreasing. So F is above the x-axis and decreasing here and here. Y'all agree with that? So that'd be negative, what is that? -5 to -3. And 0 to 2. Everybody good there? Any questions on part B? Zoom, you good?
Yep.
All right. Part C, the function h is g of x over 5x. Find h prime of 3. So first off, let's find h prime of x. So h of x, what did I say, was g of x over 5x? What? Yeah, yeah. So h prime of x ought to be 5x times the derivative of g minus g times the derivative of 5x all over 5x squared. And we want h prime of 3, is that right? So that ought to be 15. We'll find g prime of 3 in a second. And that becomes, what is that, 15 squared, 225? And we need g prime of 3 and we need g of 3. G of 3 we already found, g of 3 was 9. G prime of 3 is just f of 3, which is -2. So we've got 15 times -2 minus 5 times 9 over 225. If you want to divide everything by a 5 first, you can, and that'd be fine. But you don't have to. -30 minus 45 over 225. So -75 over 225, which, what does that come out to be? -3 over 9. Negative 1/3, right? Is that what you got? Negative 1/3. Good? Yeah, it's fine. Any other questions there on part C? Cool. All right, part D. Gives us another new function. What does it give us? P of x is f of x squared minus x. And we want to find the slope of the line tangent to P at x equals 1. So effectively, we're looking for P prime of -1. Which means we need to find an expression for P prime of x, right? P prime ought to be, well, this is f of a function. This is a composition of two functions. So f of u means take the derivative of f at u, so f prime of x squared minus x times the derivative of x squared minus x. Everybody good with that? So then this becomes f prime of, and we'll plug in -1 squared is 1, and then minus -1 is 2, so that's f prime of 2 times, and then plug in 2 times -1 is -2, minus 1 is -3. So figure out what f prime of 2 is. We'll have to go back to the graph. F prime of 2 is the slope of this at 2. What's the slope of this at 2? -2. So this becomes -2 times -3. Any questions on that? Everybody good with that? Well, you okay there? Ah. But you're good now? Makes sense. Everybody else is good? Zoom, you're good?
Good Zoom.
Good Zoom. All right, that's it. We have a quiz tomorrow. One graph question, one rate FRQ. And we'll probably have a little bit of time after the quiz tomorrow to start talking about some more FRQs or something like that. On Monday, the multiple choice was, I believe it was the applications of integration to geometry, I think. Is that what I said for Monday? I think that's what I said for Monday. Yeah. Yep. All right. Other than that, Zoom people, you're good to go. If you have questions, feel free to hang around.